Hello, Mishler Math students, the smartest and best looking students in the whole classroom. Let's talk about systems of linear inequalities. Now, before we had systems of equations, which is two lines on the plane, and they either intersect or something like that. And then we talked about, the last section, we talked about inequalities, where you draw a line and then shade one side or the other. Well, now we're going to do a system of inequalities. And for example, what we have here, x is greater than 0, y is greater than 0, y is greater than negative 2x plus 5, and y is less than or equal to 3x plus 1. Make that greater than, so it doesn't look like a 7. Okay. Now, this looks pretty complicated, but actually it's quite simple, because all you do is draw a line for each one of these, okay, and then figure out where the region is that you're going to shade. Now, I'm going to draw a straight line, and I found out I can do that, and then just erase little bits of it. So there's my dotted line at y equals 0, okay, and then draw the dotted line, that's this one right here, and then draw the dotted line at x equals 0. And pretty soon you'll see that it's obvious that we're just talking about the first quadrant. Okay, so if I erase this and make this a dotted line, and we're talking about the first quadrant. So we're left with these other two lines. And so looking at negative 2x plus 5, you see my y-intercept is positive 5. So I go 1, 2, 3, 4, positive 5. And my slope is negative 2. So that means negative 2 equals negative 2 over positive 1, or positive 2 over negative 1. So I can use either one of those. So I can start here. I go negative 2 means I go down 2 and to the right 1. And down 2 and to the right 1. Or I can go up 2, positive 2, and to the left 1. So either one of those would work, and they all give me the same thing, and that's my line. And I can draw this here. Now, it says greater than, so that has to be a dotted line, okay? And I just do that. And now it says y is less than 3x plus 1. So I go to positive 1, and 3x means I go up 3 and to the right 1. Okay, up 3 to the right 1. And that gives me my, 3 down, 3 to the left. All right, this gives me my, my last line. And this is going to be a solid line. Okay, it did a little curly Q again, so let's see if I can get it right this time. And there we go. So this is a solid line because you see it's less than or equal to. And now you say, okay, I've got all kinds of regions. I got a region here, 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 and here. Where do I shade? Now I'm going to show you an easy trick. Now first of all, you know, I already said the x and the y. X greater than 0 means I shade in this direction of this dotted line here on the y-axis. X greater than or y greater than 0 means I shade above here. Okay. Now, look where this line crosses the y-axis. And you see this is the line of y is less than or equal to 3x plus 1. So less than or equal to means that I go down, shade downward from this solid line. And so that's, you know, all along there, that's going to go below that line. This line says y is greater than negative 2x plus 5. So I'm going to shade above this line. Okay, so if I go above this dotted line here and below the solid line here, then I'm shading this region right in here. And so, and you notice that I didn't even need that other one that says x is greater than 0, because the shaded region doesn't go to the left of where these two lines intersect, but that's okay. We can keep that there. It doesn't matter. Doesn't hurt us or help us, either one. So there's my shaded region. That's how you do a simple thing like that. And so get rid of that stuff, and we'll try another one. Let's try this time. We'll try y is greater than or equal to negative x minus 1, and y is less than or equal to 2x plus 1. And this is a system of very simple, oops, I'm sorry, I missed one. Very simple system of linear inequalities. X is less than 1, and so that's my system right there. So, once again, I'll go to blue, see if I can make it. Y is greater than or equal to negative x minus 1. There's minus 1, and negative x means I'm going downhill, and so down 1, right 1, down 1, right 1, and so there's my line. It just kind of goes corner to corner across the plane. Okay? And so there's that line. It's a solid line because it's greater than or equal to. And greater than or equal to means that I'm going upward from this line. So I just put a little arrow here, shading. That'll help me in a few minutes when I'm ready to shade. Y is less than or equal to 2x plus 1. So there's my plus 1, my y-intercept. And 2x means I go up 2 to the right 1. Up 2 to the right 1, etc. And down 2 and to the left 1. And so there's that graph, and let's see if I can draw and that's another solid line. And I wiggle it a little bit at the end there. I'm going to have to get better at this. And then x is less than 1. So I've got a vertical line here that's going to be dashed line at x equals 1. And so there's my line. Use my eraser feature here and try to get this back again. I bumped something and made this thing goofy looking. Okay, here's my eraser feature, and I'm going to erase a couple of things, make that a dashed line. So there's my dashed line. So where is my shaded region? Well, I forgot to put an arrow on this second line. It's y is less than. So I look at where it crosses the y-axis, and I say y is less than. So that shades below. So I'm above this line, I'm below this line, and I have to go to the left of this line. And so that means that I'm going to shade this triangular region in here. And every once in a while I want to double check my answer and say, is 0, 0 going to be a valid solution? So let's take a look. Okay, 0, 0. That's part of my shaded area. So that's supposed to be a solution, isn't it? Let's see, is 0 greater than or equal to negative 0 minus 1? Okay, yes it is. 0 is greater than, that checks out. How about this one? Is 0 less than or equal to? And put a 0 in there, and that gets rid of that. Is 0 less than or equal to positive 1? Yes, it is. Is 0 less than 1? Yes, it is. So 0, 0 works, and so it looks, and that's supposed to work, and so it looks like I've got a good situation going on here. And let's try a couple more things here, and get rid of all that stuff. And this time I'm going to just do something real simple. I'm going to say, what about negative 3? X is between negative 3 and positive 2. What do I do with that? Well, that's pretty simple. It's you know, you just, negative 3 is right here, and x equals negative 3 is going to be a vertical line at that point, and it's going to be solid because I've got greater than or equal to, and then I got a vertical line at 2, x equals 2. Okay, there's my vertical line at x equals 2. Now the equation of this line, of course, is x equals 2. The equation of this line is x equals negative 3. So I want x is supposed to be between those two, and so that's a pretty simple task, isn't it? And on the same token, I can, and I'm not even going to graph it because I'm trying to save some time here by yelling at my videos being too long. If you have negative 1 and y and 3, well, you'd have a horizontal line at negative 1, horizontal line at positive 3, and shaded between those two. Okay? These two lines because of the signs, these two lines would be dashed lines. So that's how that works. It's very, very simple. And finally, and I'm going to stop the video here for just a moment and create a graph, and then we're going to come back and we're going to figure out how to find the equation of an existing graph. Okay, we're back, and as you can see, I've created quite a system here. And you say, well, how in the world am I going to figure this out? Well, you see there's 1, 2, 3, there's 4 lines here. So let's start with the easiest one first. A horizontal line at y equals 2. So y and 2. Now, is it shaded above or below that line? It's shaded below that line. And it's less than or equal to because it's a solid line. There. That one's all set. How about the other one? The vertical line here. That looks like x is, okay, it looks like x is going through here at -1, okay? So x, and it's a dotted line, so x, and it's shaded to the right, okay? So I'm going to say x is greater than -1, okay? And now I've just got the two slanted lines. Let's try the dotted line here going downhill. Now, that's, first of all, it's going to be a y. And it's going to be greater than or less than. Well, it's shaded above that line, so it's going to be greater than. And where's my y-intercept? My y-intercept here is -1. Okay? And what is my slope? Well, it goes down corner to corner, so my slope has got to be -1. So I just say -x minus 1, and that equation is done. So we're done with that one. We're done with this one. We're done with this one. We just got this one left. And this one passes through the x-axis, or the y-axis rather, at, let's see, 1, 2, 3, 4, at -4. Okay, it's a solid line, so and it's shaded. If you look here at the shaded region, it's shaded above the line, isn't it? And so I'm saying greater than or equal to, and now all I need is a slope, and that's pretty easy. I just go from here. I go from here to here. I went up 2 and to the right 1. So my slope is 2, and that's 2x minus 4. And so there's my system of equations. There wasn't any rocket science involved here. I just look at each line and write the equation that matches up with that line. And then as far as a greater than or less than or something like that, like I said before, just look at the line where it crosses the y-axis. Am I shaded above or below that line? And now it'll take a little practice for you, but I think you'll get it. And my video now is less than 13 minutes. I am so proud of myself. Have a great day.